Alright, so hello grade 11s. Hello. Okay, hello grade 11s. Hello. So, yeah. I think grade 12s need to also realize that you guys, if you are in grade 12 currently, you are going to be writing a June exam that's out of 150. That's going to have both grade 11 aspects of the geometry and also the grade 12 aspects of the geometry. I'm currently doing grade 11, of course, at the moment, all right? But as a grade, As a grade 12 learner, you benefit from the idea or the premise of actually ensuring that you understand the work that you did in grade 11, because it will be part and parcel of the June paper that you will be writing, your paper 2. Just as much as the grade 11s will also be writing 2 papers during June exams, that will also have like these aspects as well. So yeah, till next time to the grade 12s, when I actually do have a session. But for now it's grade 11, so we're doing geometry. We continue with geometry. Last time we did the last time we ever had a session for geometry, we did that theorem that has to do with cyclic quads. All right, we looked at how to find angles, that are basically missing where cyclic quadrilaterals are concerned. Okay. But also additionally, I think something you guys need to also know is that sometimes with cyclic quads, there are situations where we are required to prove that a quadrilateral is actually a cyclic quadrilateral. And when we are required to prove that, there are 3 conditions that basically lead us to that conclusion. All right, 3 important vital conditions in a diagram that lead us to that conclusion. All right, and it's very important to know those 3 conditions, because when you know those 3 conditions, then you are able to prove that a particular diagram is a cyclic quad if you know those 3 conditions. Okay, there's going to come a time when I'm going to do proof type questions, and when I do proof type questions, I'm going to go back to all the theorems that had to do with proof type, and then I'm going to actually cover those. But for now, like I had said when I started or when I had continued the Euclidean geometry, I am just going to do the theorem, introduce a theorem, look at the diagram, we discuss how it applies, look at some foundational basic problems, and then game challenges after that. So I'm intending today to actually look at the tangent related theorems. So I'm just going to write the word tangent. Okay. Now the thing is, what is a tangent first and foremost? So let's look at this thing called a tangent. A tangent basically is a particular line that basically will touch a circle specifically. In this situation, it will touch the circle at one point at its circumference. Okay, just one. Okay, that is what we refer to as a tangent. Okay, so that means since it's a straight line, okay, I mean there could be a tangent there could be a tangent at this point, there could be another line that just touches the circle at one point, just one point. Okay, and you can see that our tangent can be of varying gradients, meaning the gradients of the tangent can vary depending on where that tangent is touching the circle. Okay, so it touches the curve once, just like Niani said. That's what a tangent is. Tangent is a line that touches a curve, or that touches a curve. And the thing is, what basically this means is that a tangent doesn't necessarily have to touch a circle once. It can be a parabola function, for instance. A parabola function, it could be a function that is a curved function, where a tangent simply just touches once, all right, and that's all. So it touches a curve once. Okay, so since a circle is a curve, touches a curve once. Sure. Today I'm telling you, there's a lot of things that are not so great. The writing is not great. The network earlier on was doing funky stuff. So it's just a lot. Okay, a lot that is just not agreeing today. It's not flowing, not feeling. Okay, so as long as we understand what a tangent is, okay, tangent touches once, okay, just as long as we know what a tangent is. So the first theorem we are going to look at is this one. The first one we are going to look at related to tangents, that a tangent to a circle, so a tangent to a circle is what? Is perpendicular. Now this is not a word you are hearing for the first time, the word perpendicular. A tangent to a circle is perpendicular to the what? To the radius at the point of contact. So let's review this again. Yeah. A tangent to a curve is perpendicular to the radius at the point of contact. So in other words, if you have this tangent, and let's just say there's a radius, so obviously the radius comes from the center of the circle to the circumference. Okay, so that there is a radius, that there is a tangent. This theorem is saying a tangent to a circle is perpendicular. A tangent to a circle is perpendicular. So there is perpendicularity. Okay, tangent to a circle is perpendicular to the radius at the point of contact. Where is the tangent and the radius meeting? At the circumference of the circle. So this is the point of contact. Thank you, Mr. TK, for the 3 amazing roses. Really appreciated, sir. So we say that a tangent to a circle is perpendicular to the radius at the point of contact. Okay, so when in your diagram you'll be given this, that's what you'll be given. This is what you will see. You will see this tangent touching the circle there. You will see the radius, right? But you will not see the perpendicularity of the what? Of the tangent and the radius at the point of contact. Okay. Thank you so much, sir. Thank you. So that's O, the center. Let's say that's line AB, that's the tangent. And let's just say that is C, the point of contact. Okay, so this theorem is saying a tangent to a circle is perpendicular. A tangent AB, is perpendicular to the radius. Radius is the line from the center to the circumference at the point of contact. So at this point of contact, what is the result? The result of the tangent and the radius meeting at the point of contact is what? We say that the tangent, okay, if this is Yeah. I think you guys get the point. And I'm sorry for the squiggly handwriting. I mean, for the squiggly writing there. But let us rub it off because it is rubbable off. Let us rub off the pen because it's rubbable. So there it is. See, there's our tangent, center, radius. So this is the result. The result is that if the conditions are such that we have a tangent and a radius, we say that the tangent and the radius are perpendicular. So you would basically then say the following. Based on this diagram, you can then say OC is perpendicular to AB. All right. Yeah. And what's the reason? What's the reason for saying that? You are going to say tangent perpendicular to radius. Okay. And that's simply it. All right. So obviously that comes with a lot of conclusions like OCB, for instance, angle OCB is actually equal to 90 degrees, right? As well as OCA, angle OCA is also equal to 90 degrees, right? Because the radius and the tangent have a relationship of perpendicularity at the point of contact, all right? At the circumference of the circle, okay? Wow, thank you again, Mr. TK. Really appreciate that, sir. Really appreciate it. These gifts, they are amazing, guys. There's no great feeling than when a teacher is teaching and then you just see the gifts flying through the screen. You know, I don't know. It has this feeling of like, wow, thank you. You know. I know sometimes we come into the live, we listen and we receive a lot, and it's all good and nurturing and nourishing, but I must say there's something about the gifts flying through. It's just beautiful. So thank you so much. I really appreciate Mr. TK a great deal. So let's continue. So that is the theorem. A tangent to a circle is perpendicular to the radius at the point of contact. This is very key. All right. We talk of perpendicularity of the radius and the tangent at the point of contact. Okay. Mfana Mbele, I would encourage you to go and check out my video on diameter, you know, angle in a semicircle, angles in a semicircle. Diameter subtends 90 degrees at the circumference of the circle. All right. And we did the diagrammatic representation of that. I think it would be very important for you to check that out. Okay. Then we also have, guys, the converse of this theorem, which is basically used to prove. This one is used to prove that a line is a tangent. Very important. Okay. It is used to prove that a line is a tangent. The converse of this theorem. What does it say? It says if a line is drawn. Okay, guys, I avoid mentioning theorem numbers because when you are examined, you are never going to be asked theorem number. Okay, even though it does say in the textbook theorem number 7, but I don't talk about theorem number. I simply want you to know what the theorem says. That's important to me. And then I also want you to know the diagrammatic representation of that theorem. So the converse of this theorem that says a tangent to a circle is perpendicular to the radius at the point of contact. The converse says if a line is drawn perpendicular to the radius, which means we are given perpendicularity. If a line is drawn perpendicular to the radius, okay, at the point where the radius meets the circle, then the line is a what? Is a tangent. And you'll remember I said that this theorem is very much applicable whenever we are asked to prove that a certain line is a tangent. Okay, yeah. Okay, so what I'm going to do is that when I do the proof types, then I'm going to actually bring in all these converses and I'm going to explain them further so that you can see their relevance. For now, I'm just going to leave that statement as it said, it is stated. Okay, all right, because I'm going to delve into it when I do proof type questions. Very important when we do proof type questions. Okay, so let's look at some examples under this theorem. You're very welcome, very welcome, very welcome, very welcome. Abuja, I know. Thank you so much there. Very welcome, very welcome. So we have T, we have X, we have 50 degrees, as I know you know. We have A, we have B. Okay. And then O is the center, of course. So we are asked to calculate X, and we are told ABT is a tangent. All right, so we are here. We are asked to calculate the value of X. This is a line from the center to the circumference. We can see that ABT, we are told, is a tangent. So what is the relationship that exists between OB and AT? Okay, what do we say about the tangent that passes or touches the circumference of the circle and meets the radius at the point of contact? We say that this angle here is 90 degrees, obviously. So we'd say OBT is equal to 90 degrees. And our reason, as I said to you, we just simply say tan perpendicular to radius. That's it, guys. Then we go and fill in, update our diagram. It's important to do these things. Update our diagram. We can either put that box that says 90 degrees, the box. Okay, yeah. Then in triangle OBT, what do we see? We see that 50 degrees plus 90 degrees plus X is equal to 180 degrees. And we know that we can use a variety of reason, sum of angles in a triangle, interangles of a triangle, and so it goes. So X is equal to 180 minus 140 degrees, which basically means X is equal to 50 degrees. All right, so that's the value of X, done and dusted. Okay, yeah, and that was that. Nothing to it, straight to the point. We used our theorem that we've just learned, because we know that a line that is basically from the center to the circumference is called the radius. The line ABT, this is a tangent. The relationship that exists between this OB and this ABT is 90 degrees because there's a perpendicular relationship at the point of contact. So therefore we then conclude, since we now know that OBT is 90 degrees, angle OBT is equal to 90 degrees, the reason is tangent perpendicular to radius. We just used the theorem that we've just learned. Then we find the missing angle. We update our diagram. We write the 90 inside. Then we can see that this is an OBT triangle. So therefore we know that the sum of angles in a triangle is 180 degrees. We know our reason. We get the value of X. X is 50 degrees. Actually, yeah, x is definitely what's happening here. Yeah, it's a beautiful 50, right? Is it? No way. Definitely. Thank you. Right. No ways. Imagine if we said 50 degrees. That would mean that our subtraction is definitely at a place where it shouldn't be. Okay. And what a silly mistake to make at the end when everything has been done so 100% well. Then we butcher it just at the end because our subtraction is not on point. You know. Talk about a way of throwing away marks, eh? Right, so yeah, just be careful. Don't be like me. Don't be seen on TV. Right? Yeah, okay. Let's do this one. So here is a, what is it? What do they usually call these things? Here is a plug for you grade 11s. Make sure that as a student of mathematics, you grasp the maths very well. Do you know why? Because one day you might just be able to make this a side hustle. Do you see how many people in this live session come in and they ask, help me with this, help me with that? Can you imagine? Now imagine you being a student and you are at varsity, and maybe, just maybe, even though you do have all of these bursaries and all of that stuff, you just want extra money. How many grade 8s and 9s do you think need help with maths? How many kids are struggling with maths? And how many kids could you possibly help yourself if you can just make sure that you understand the maths? So here's a possible side hustle, possible plug in the future. So don't take it lightly. Grasp these things. Just maybe you might have a side hustle. Who knows? I don't know. You know. All right. Look at people like Presh that can actually. I remember when I had her with the answering some questions here and helping, and you could see even with the leading and so forth, helping out the other person. You could yeah. So please consider these things. Anyways, always the center. Remember, we know that ABT is the tangent. Now we are asked to find what? X, Y, and Z. So where do we start, my beautiful people? I'm sure you can see, since ABT is a tangent, this is a diameter, but of course, half of it, the radius. Okay, yeah, OB is the radius. The radius and the tangent, obviously, at the point of contact, we know most. So what can we say? OBA is equal to 90 degrees. Euclidean geometry. OBA equal to 90 degrees. Reason? Tangent perpendicular to radius. Obviously, I can see the radius OB just intact. Okay. Then, since this, all of it is 90, do you see now I can say X is equal to 90 minus 35, because X plus 35 is equal to 90. X is equal to 90 minus 35. Reason? Angles. Complementary angles. Because remember, since this is all 90, the X plus 35 gives me 90. That's why I say X is equal to 90 minus 35. Reason? Complementary angles. So X is equal to what? What's 90 minus 35? That gives me 55 degrees. Update. We're always updating. That was the 90. We updated the 55. Now, since now we have 55, what is the value of Y? Right? Now, someone said something earlier on about the diameter. Okay? And hopefully that person is still here in this life, or maybe they left a long time ago. Right? So hopefully that person would be the best person to be able to answer that. It was Mfana Mbele. Mfana, I hope you are here. You see that COB is the diameter, since this is a line passing through the center to the other side of the circumference. So what does that tell you? The value of who? The value of y. Okay, y, we can find the value of y immediately. All right, y, because this is the diameter. So we say y is equal to 90 degrees. What's the reason? Angles in a semicircle. Okay. Angles in a semicircle. Hopefully you understand that. Okay, so now we have the 55 degrees. We now have the 90 degrees, which we know for sure that y is 90 degrees. Very important, because angles in a semicircle, we know that the diameter subtends 90 degrees at the circumference. Then the triangle, in triangle CDB, what do we know in triangle CDB? We have Z is equal to 180 minus 55 degrees minus 90 degrees. Right? Reason, sum of angles in a triangle, or you can say int angles triangle. Doesn't matter. Sum of angles in a triangle is also fine. It's an acceptable reason. The Z value. Okay. It's your boy Uzi. What in the world? Oh my soul. What is happening there in the comment section? Gladys Knight is having a field day with his boy Uzi. Okay. Right. Okay. Z is equal to 35 degrees. 100. Finished. What more, guys, can we ask for? Yeah. What more can we ask for? Oh, he was confused. Oh, I was like, what's happening there with you and the boy? All right. Okay. Okay. Let's have some beautiful guests come up and answer some questions here. I know you guys are feeling all sorts of feelings of joy. You want to come up. You are eager today to come up and answer questions. Okay. We play this by request, guys. It's always beautiful to hear your amazing romantic voices. As you romance the mathematics. Remember, you guys are romancing the mathematics, nothing else. So hence, I'd love for you guys to come up. There's the question. There it is. We know that ABT, O is the center, ABT is the tangent. So all we want is to find the value of x. O is the center, ABT is the tangent. So I just need people to request, and they can come up and have a field time answering the question for us. Right, I am not going to request you. You must request, and you must come up. I will just accept you, but you must be in grade 11 and grade 12. Do not come up here when you are at varsity wanting to just come and shine on my platform. I need the relevant people to come and shine. Okay. All right. So not all at once, guys. You don't all have to at once go and press the request button, but please request so I can invite you up. It's better to invite people that want to come up. Oh, Shandumaki, Jonga. Shandumaki, also you are very kind today. I really appreciate your kindness. I see you second time extending a beautiful rose. You guys, you see this romancing of mathematics. It's happening here. People are sending roses. I just need someone now to come up and say the right things so that we can find the value of x in this problem. Just lead us nicely from point A to point B to the last so that we can get the value of x. Leading us very nicely. So I'm waiting for potential requesters. No one's requesting so far. I'm not going to extend an invite to people if they don't want to come up. So you must come up yourself. Someone said, can I try? It was Odysseus. Come, Odysseus. Let's see. Hopefully you are in grade. You are in the right grade. No, guys. Mangos is requesting. I don't want your answers in the comment section. I'm going to actually close the comment section so that nobody can see his comment. Mangos, hello.
Yeah, sanibona.
Sawubona mama unjani?
Ngiyaphila.
Oh, hayi ngiyaphila now. So, Mangosi, we just want some help here. We want the value of x, Mangosi. So we just want direction, way forward and, statement, good reasons, just everything, Pashash.
Okay. Angithi u-ABO. Angil-ABO u-90.
ABO is 90. That's very true.
Yes, so sebenzisa wona. Sithi u-35 angle u-35 degrees plus.
So firstly you said angle, AB angle ABO. So this side.
Yes, u-90.
This side.
Yes.
ABO is equal to 90 degrees. What's my reason?
Ngithini? Angazi yini perpendicular to a tangent, radius perpendicular to a tangent.
Amen. So tangent perpendicular to radius. All right. Hi. Sibambe yona. Tangent perpendicular to radius. Yeah, very important, that is it. Next step again.
Yes, bese sithi u-angle BOT plus u-angle BTO of which x is equals to 90 degrees.
Okay. So like 35 degrees plus the x is equal to, you said, 90 degrees.
Yes.
Oh.
Exterior angles of a triangle.
Exterior angle of triangle.
Yes. Bese since x subject of the formula is minus 35 ku-90.
Hey, wait, Mankosi.
Yes, bese sithola i-answer.
Ngubani Mankosi?
Angazi.
Habe.
Angazi, angiphethe i-calculator. Nje umqondo wami awusheshi nje ukubala. Ngisebenzisa i-calculator naku-2 plus 4 mina. Nekhanda eqinile Nkosi yami.
Oh Mankosi, Nkosi yami. Yabona nesibongo negama lithi uMankosi. Nkosi yami. I know, that's fine. So x is equal to 55 degrees. No, thank you very much. That was very nice, Mankosi. I love the way you did not conform to the problem that we did previously. You found your own way to getting to the answer. I love that. It's beautiful. So Mankosi did not use the interior angle of the triangle. She did not say AOBT is 90, but rather she said OBA is 90 degrees. She gave the reason that's correct, and then she further on went on to say 35 degrees.
Mina ekuqaleni bengingakangeni ngenkathi nenza problem leyo kuqala. That's
beautiful, Mankosi. Even more beautiful, because it's even good. You were just doing your own thing. No, this is beautiful.
Until OBT, until OBT u-99.
Yeah, I'm 99.
Nathi i-reason.
Kaloku same reason. Tangent perpendicular to radius.
Oh, okay.
Yeah, then ke ngoku sabe sisebenzisa ama-interior angles. We used interior angles of a triangle, the sum of angles in a triangle, instead of using exterior. But I love the way you approached it. It's also 100% correct. Thank you so much, Mankosi.
Thank you.
Mankosi, ungwase-KZN ngimamele ilanto kwisizulu lesi.
Yep.
Oh, okay. Kaloku abantu base-KZN bayapaselwa i-maths pha. Yo, KZN ne-maths.
Hawu mina Nkosi yami ngiya-upgrade mina ngiya-upgrade.
i-upgrade. So uyabhala la ngo-May, June?
NgoNovember.
Oh, November. Okay. All right. No. Hayi ke ungathi uza kakuhle Mankosi. You must keep it up, eh? Keep up the fire. Don't let the fire stop burning. Ungathi uza
Okay,
kakuhle. Yeah.
thank you.
Thank you, Mankosi. Really appreciate you. Thank you. Goodbye.
Kuphunywa kanjani la?
Hayi ngizokukhupha sowari. Kuphunywa kanjani? Oh, Nkosi yami. No, that's beautiful. Okay, nice. Okay, let's have someone else come up and have some fun with us in the platform. Okay, we are still saying O is the center, APT is the beautiful tangent. Let's see. Okay, there's people that have already requested, and I just chose the first person that was there on the request list. Don't worry, we'll come to everybody else that I see there. I see the people that are there. I will come up to you. Okay, I see this one. Something happened there. Mfana Mbele. The only Mfana. The only Mfana.
Yebo sir, kuyaphileka sir.
Kuyaphileka Mfana, unjani Mfana?
Kuyaphileka sir.
Yeah, no, the only Mfana in the world. Ewe Mfana, we are here, my leader. We want the value of A.
Of E, okay. Alright, okay. So qala sithi angle B is equal to 90.
Manje.
Because
Angle bani?
angle B.
Okay.
Yes.
When you are saying angle B, what are you talking about? Which, you see, angle B is basically here. You see, this is point B, but then angle B is everything here.
I'm talking about outside.
Yeah, but
outside angle, yes.
You need to specify. If you are talking about the outside, you must use your letters to specify that angle that you are talking about.
Okay. I'm talking about the angle OBT.
Thank you.
Is equal to 90 degrees.
Thank you. You see, that's very important what I just asked you to do, Mfana, because if you just say angle B, you confuse me. But if you specify the angle B according to the use of the letters, either OBT or OBA, you must specify. Please, it's very important. Okay, reason.
Yeah. Tangent perpendicular to the radius.
Amen. Tangent perpendicular to radius. All right. Update.
Yes.
Update. Then?
Okay, masiyabuya sithi angle OBT is equal to angle A plus angle O.
Okay, Mike. Angle OBT is equal to angle
A plus angle O.
Angle A plus angle O. Which O? Are you talking about O, the reflex? Are you talking about O, this one?
I'm talking about inside.
Okay.
Oh.
So here it's fine. You can just tell me 2A plus 3A is equal to 90. You see, you can just use what you have in there.
Yes.
Yeah. So what's the reason?
Exterior angle of a triangle.
Okay. I can see Mankosi's influence has come to the live session. Mankosi's influence.
You 5A. 5A
is equal to 9.
9 divided by 5, both sides.
Yes, which gives me what?
90 divided by 5.
Then you also, like Mangos, you need a calculator. You only know 2 plus 2.
I need a calculator. There's no way.
Mangos is influence. Ay, 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 yay. Yeah, I even switched off the comment section so that you are all alone.
Yes.
Yeah, so you can give me the answer alone. So what's the answer alone?
Yes. Calculator amazi kude sela. Kude kakhulu manje khona nje le phone manje ngeke ngikwazi ukuphuma ngiyabonga ngiyobala ngayi. Ikude kakhulu.
Oh, okay. Okay, then that means you guys don't want to give me the answer. So I am going to move on. Okanye is Alonde bringing me the answer? Okay, so
I want to say.
hello Alonde, are you coming to give me the answer of 90 divided by 5?
Yes, it's
Oh,
18.
It's 14.
18.
You said 18. I thought you said 14. 18.
Yes.
18 degrees. All right. Okay. Thank you so much. Really appreciate that. All right, Mfana, thank you so much, my leader. Let's give Alwande a chance as well.
Yes.
Thank you. Let's give you a chance. I hope you are well, Alwande.
Yes.
Yeah, and you are ready to give me the things that I need for this particular problem, even though I haven't yet sketched the diagram, but I'm sure you are ready. Okay, maybe let me draw that a bit bigger because it's small here. So here, okay, let's do this one. We got that, we got that O there. MCBX 40 degrees. Our tangent there, which is ABT as usual. We've got D there, we've got a Y. Right, let's go. You're up. Disappeared. Okay. I think that didn't fire well. Planety Young tips. Okay guys, I think that didn't fly well. The Planety Young tips.
Hello.
Are you well?
I'm also.
No, I'm doing very well, Planety Young tips. Hopefully you're in grade 11 or you are in grade 12.
Okay.
No, I'm asking, is that true or is that false?
What?
Grade 11 or grade 12?
I don't understand when you say grade. I'm doing Form 4. I'm a
Oh, you're from Zim.
Yes.
Oh, nice, man. That's beautiful. No, you can lead us along, my leader. You're here to answer us.
Okay.
Let's go, man. Let's go. This is beautiful. We got a Form 4 guy in our life. That's beautiful, man. Now I feel very much international, man. Like I'm no longer influencing South Africans. It's all over the show now.
Okay. Okay, so now what I know is that when a straight line and a tangent, when they meet, and when a straight line and the diameter, when they meet, they form 90 degrees. So, which means angle CBT is equal to 90 degrees.
Okay, CBT is equal to 90 degrees. That's true. Reason?
Yes. So if it is 90 degrees now, we already given, is that 40? We are given 40 degrees there.
Okay, so just before that, Planet Young, okay, so we wrote the statement CBT is equal to 90 degrees. I fully agree. But what is the reason? What reason do you guys write as the supporting reason why you say CBT is 90? What would you say is the reason? Because here in South Africa, we write reasons, my leader. Every statement is followed by a reason.
Okay, my reason is that when a straight line and the radius, when they meet, they form 90 degrees.
Okay, so I'm guessing, let's just formalize it for my people in the live. A tangent is perpendicular to radius. Thank you so much. I think I get you. I understand you. I understand. Okay, let's move on next. So that means that's 90, this one.
Yes.
Yeah, all right.
So now what other thing I know is that I just want to apply the rules first.
Sure.
An angle which is formed, or an angle which is formed in a semicircle at the circumference, that angle is 90 degrees.
So which one are you talking about?
So I'm saying BDC it's 90 degrees.
BDC is 90. So BDC is 90 degrees. Which is also y, our y value. So y is 90. Okay.
Yes.
Yeah. The reason you said, so basically I heard you. So we officially say angles in a semicircle. That's how we state it. That's kind of the acceptable reason we use. Okay, I am with you. So we update there. That's 90.
Yes.
Yeah, we are coming close. We need m and x now. We need m, we need x.
Yes. So now want to find the value of x first. How can I find that value of x? So is what I said the CBT is 90 degrees. So
CBT is 90, yes.
It's 90 degrees.
I've
given 90. I given 40 degrees there already. So to find x, I say 90 minus 40.
So x is equal to 90 minus 40 degrees. That's true. So x is equal to what?
X is equal to 50.
Thank you, sir. We would write complementary angles, which is why we state that x is equal to 90 minus 40. Complementary angles. Thank you. X is 50. Now we need that m.
Now for m, or angles in a triangle, or they add up to 180 degrees.
Very true.
Yes. So as for now, I say the value of b, which is 90, plus the value of y there.
90
plus
this 90 here.
Yes.
Yes. So which triangle
plus
are you
50,
looking at?
Plus 50, the value of x.
Okay, so you're looking at triangle CBD.
Yes.
90 plus 50 plus?
Plus, I can say plus x. Just a letter, they add up to equals to 180.
So we're wanting the m, so we can say
Yes,
m specifically.
Okay.
So that's the m there.
Yes.
It's equal to 180 degrees. What's the reason? Or your reason? Okay, we usually say sum of angles in a triangle, or we can say interior angles of a triangle.
Okay.
Angles of a triangle. Then when we solve for m, we get what?
When you solve for m, we get okay, to say just the 8 first, the 90 plus 50.
Which gives you what?
140. 180 minus 140. So our m is equal to 40 degrees.
Awesome. Okay. So my leader, you are spot on. I can see obviously that things are slightly here it's just that here in South Africa in our curriculum, we seem to have formalized the reasons, we have formalized reasons. But I hear the logical explanation for everything that you have stated, which means to me that you have an understanding of why we should be doing what we're doing, which is amazing. All right.
Yes.
So yeah, really appreciate a Form 4 learner from Zim actually gracing our live session. So which part of Zim are you from, bro? Are you from Bulawayo? Are you from Gweru? Are you from Harare? Where are you from?
I'm from Chegutu.
Oh, okay. See, none of the above that I listed. Okay. And so Form 4 is like is it the final year of like your high school?
Yes, it is.
Yeah. And I believe you guys do even advanced mathematics in Form 4, eh?
Yes, we do them.
Yeah. And the guys, to those South African learners that don't know, these guys, when they do their Form 4, their Form 4 is so good, man. When those guys come to South Africa to come and study at our institutions, they usually know that year one mathematics that is done by many learners, and they feel out of depth with that mathematics. So you guys are very privileged. I think your education is quite, it's at a very, I must say, very high level. That's for sure. Yeah. Right. Thanks, Planety Young. Is this like a brand of yours, the Planety Young Tips?
Yes, it is.
Oh, okay. And what do you do?
No, I just do it for funny, nothing more.
Okay, no, I hear you.
Yes.
No, thanks, man. Thanks for joining. Really appreciate it. Cheers, bro. Cheers.
Thank you.
All right. Nice. That was beautiful. Love that interaction. No doubt. Okay. I wonder who is my next victim. Okay. Is that like an appropriate term to say my next victim? Yeah, I've switched off the comment section so no one can say anything. Even if you are saying it, I can't see it, which is great. Yo, what is happening? Blurriness is overtaking. Okay. And guys, I'm actually working tomorrow, eh? So much for it being a Sunday, eh? Supposed to be resting, for crying out loud, but me is working. All right, BAT. Right. All right, I had a guy. Let's have someone. Let me pick on this person.
Hey, sir.
Hello, Pressure. Are you well?
I'll be fine.
You'll be fine. Why are you not fine?
Nah, not really.
Aibo, why? What is happening?
Yes, yeah, I'm so weary. I'm thinking of sleeping, but my mind is saying something else. So basically, I'm fasting. I'm fasting.
You're so sleepy, but your mind is thinking of something else.
I'm fasting. The thing is, like, this past, I think it was a week ago.
Yes.
I was scrolling through TikTok.
Yes.
And then I saw this post. So every time I'm thinking of sleeping right now, it's ringing in my head.
Yesterday, what did the post say? Let's keep
It
everybody
said,
up. Let's keep everybody up with that post, with that message.
don't stop when you're tired, stop when you are done.
Yo. Yo. Hi. That's a sermon for years. Yo, don't stop when you are tired. Stop when you are done. So you are tired, but you are not done. So you can't.
So I can't sleep.
That is so funny, man. That is so hilarious. Okay, no, that's fine. I'm happy that you are here in the name of stopping, not when you are tired, but when you are done. So you feel like you're not done. So that's why I've put two beautiful problems for you so that you can be done, hopefully. All right.
They don't look so beautiful.
No, they look very beautiful. I mean, you need to talk to them, you need to make, please make sure you keep eye contact. You keep eye contact with the problems. You talk to them, you listen to them, you apply and you do the things that need to be done. So ABT is still the tangent and O is the center. We want the value of x. X is this angle here, and then OY is this angle there. And then you are given the 50 degrees there, which is this angle here.
All right. So angle OBT is 90 degrees.
Okay, angle OBT is equal to 90 degrees. And what is the
tangent perpendicular to radius?
Okay, so tan perpendicular to radius. All right. I'm sorry for the squishiness there.
Okay, and then we know that OB is equal to OC, right? Which makes it right. Yes, is equal to OC.
Is equal to OC. Really?
Which is radi.
Really?
Yes.
Wow. OB is equal to OC. Man, I didn't see that. OB is equal to OC. Okay.
Right? Which means angle OBC is 50 degrees. Angles opposite equal.
OBC is 50 degrees. Oh, wow. OBC is equal to 50 degrees. And you're saying the reason?
Angles opposite equal side.
Sure. No, that's very
Which
deep.
Means
that's
X
deep.
is equals to 40 degrees. Reason being complementary. We did state that OBT is 90 degrees, right?
Yes, X is equal to 40 degrees.
40 degrees, yes.
Complementary. Yeah.
And then
pushing out, yes.
X plus Y is equals to 50 degrees exterior angle.
X plus Y is equal. Whoa! Wowza! Wait. Let's see. For some of my people, like I feel like I'm also a bit slow here. So we're looking at this triangle BCT. X, you have it is 40
plus Y
plus this Y
is equals to 50 degrees.
Oh, yo. X3. Oh, yo. So it's 40 plus Y is equal to 50. Exterior angle.
Yes.
Yeah. You are dishing.
Which means Y is equals to 10 degrees.
Wow. Y is equal to 10 degrees. Now, who can dispute that? Wow. I know, I'm not fighting. This is, sort of like, yeah, you know your stuff. Yeah. And the thing is, even though you feel like sleeping, you're not done. Here's another one.
Okay, let's see.
Okay. So you are given still ABT. This is the center. Okay, this here is the center O, obviously. Then we need A, B, and C.
Right. Okay.
Wait. Just wait a sec here. I'm just checking if this is a fair question in the sense that have I... Okay. All right. Given the fact that, yeah, this is the coverage, definitely, yeah. Okay, it's a fair question. Thought I was unfair. No, you're very fair.
Oh, okay. So angle. So the center is O, right, sir?
The center, yes, is definitely O.
Yes. So OBT again, it's 90 degrees.
OBT is 90, definitely. Reason?
Tangent perpendicular to radius.
Tangent perpendicular to radius. Yes.
Is equals to 52.
A is equal to 52
Wait.
degrees.
Complementary.
Comb angles. So just for those who obviously like would probably say A plus 38 is equal to 90. All right, it's okay to say A is equal to 52 degrees, sort of like the calculation done. You know, A is equal to 52 degrees. Okay, because it's that 90 minus 38 degrees, which is 52. Reason, complementary angles, because remember we said OBT, this angle here is 90. So 90 minus 38 gives you 52 complementary angles. Thank you.
Sir, can you name the vertex there on the circumference?
Oh, I see. Sorry, let me just check. I think it was actually named, but it's just that it's me when I drew the diagram. I'm sorry
Okay.
about that.
And then angle E is equals to 90 degrees.
Angle E.
Is angle E or angle BED.
Thank you. It's like time for that, right?
Yes, is equals to 90 degrees.
I
Angle in a
was saying,
semicircle.
Crash, it's time for that.
But we're not done, so we're not
Yeah,
sleeping.
that's the problem, right? That's what's keeping us here, is that it's time for this, but then we are not done, so we have to continue. So angle BED is equal to 90 degrees. Reason?
Angle in a semicircle.
Sure. Okay.
There.
Okay.
Thank you.
Angle in a semicircle. Yeah, don't worry. I picked up my own error. I was like, what am I doing there? Sorry. Yes.
And then angle B is equals to
Let's update
30.
it,
Oh,
90.
angle B is equals to 38. Sum of angle in a triangle.
All right. So for those who are watching, Precious is looking at triangle DBE, that triangle.
Oh.
So in that triangle, we have 52, we have 90. What's missing is B if we sum it to 180. So B, you said B is equal to?
38.
38. Yeah, and to the people that are watching and they're like, hi Bob, what? But Precious is just writing the answers. Guys, this is fine. You can do this, right? In earlier grades, in grade 9 and grade 8, it we may have insisted a lot for you to guys write the statement with its accompanying equal to 180, you solve. But like when you are in these like grade 10, 11, and 12, hi guys, you are in this thing, you are saying 52 plus 90 plus what will give me 180. So B is equal to 38 degrees. And you just write the reason. Okay, so your reason is?
The sum of angles in a triangle.
Okay, sum of angles in triangle. Okay.
Then angle C is also equals to 38 degrees.
C is also equal to 38 degrees. You kid me. How?
Angles in the same segment.
Oh, yo. So you have these theorems still there in your head.
Yes.
You see, that's the thing, Presh. Like, I just find that a lot of times you move from one theorem, people tend to forget that theorem. So, seeing as though we are in the theorem now of tangent perpendicular to radius, people's mindset is on the theorem tangent perpendicular to radius. And then the tendency is that they forget what they just came from. And I'm just saying, hey, this amnesia, this mathematic amnesia of just forgetting things that we've just learned, hey, that thing is not healthy for us and our performance. So I love the fact that angles in the same seg. Okay, nice. Sure. Okay, I think you're done. I'm not gonna give you another one. Like yo. All right. Maybe for the people that want to take a screenshot and they're like, "Sir, we didn't see that." Here it is, guys. That was 2 good problems. Fresh doing the things as if like they're nothing. Yeah, thanks. Thank you, Fresh.
Bye.
No pressure, eh?
Okay, so bye.
Bye. Okay. Let's see. We need another. Let's look at another one, guys. Another one. Okay. I'm basically doing all of these so that game challenges are not game challenges. We don't have any. All right. So this is the whole point of doing all of this so that we don't have game challenges. Okay. Let me just write both of these so that okay. All right. I think we are ready for some beautiful guests. Guys, I'm sorry for switching off the comment section like I have, but yeah, I have reasons. Look, I don't want people interfering with people and answering and all of those things. So, wow, this name. Say it for me.
But this is
What a name. What a name. Is that like your real name or is that a name that you have on TikTok?
it's a name I have on TikTok.
Oh, okay. And what is the inspiration behind the name?
Just the famous what's this? A Greek god.
Oh, okay. And what about this famous Greek god? What about him? Like, what's these unique characteristics that you kind of like?
Odysseus kind of is like a loyal person, especially towards his wife. So yeah.
Wow. Dude, are you married?
No.
Okay. You have every intention to, it seems.
Yeah.
Okay. In the distant future, in the near future. All right, let's get to the maths. Let me not get too personal here. All right, buddy, all I need here is to get
So
the the values of x, y, and z.
Less
So you can,
about Odysseus and more about solving the problem.
yeah, definitely we can get to that. So let's do that. Let's do that. X, we need x, we need y.
I see myself as the next Einstein.
Awesome. That's beautiful. Let's do this then. Let's get these small fry problems out of the way so that you can get onto your Einstein ways.
Yeah. X and Y. X. Okay.
Yeah.
So yeah. So we are given that ABT is a tangent, right?
Yes.
Then angle. Can I call it angle OBC, which is equals to 90 degrees.
OB.
OBT. T.
All right. OBT definitely.
Yes.
OBT is equal
degrees.
to 90. Definitely.
Yes.
Reason?
And the reason is tan perpendicular to radius.
Awesome. Tan perpendicular to radius.
Yes.
Nice. Very smooth.
And also angle
Update.
Yes, before I can get X, I want to get Y first. So angle CBT, angle CBT is equals to angle D.
CBT is equal to angle D. Oh, okay. So I'm guessing you're jumping to the tan chord.
Yeah.
All right. So C. You said angle? Go ahead.
CBT.
CBT. CBT, yes.
Is equals to angle D, which is equals to 60 degrees.
Is equal to angle D, which is equal to 60 degrees.
Yes.
CBT is equal to Y, which is equal to 60 degrees. Okay, reason?
Yes, Tangent Theorem.
All right. So shame for my wonderful engaged viewers. Of course, you're probably like, what in the world? At least because we haven't touched on the Tangent Theorem as of yet. It's still coming up. We just started.
Okay.
Yeah.
So
No, but it's fine. No, it's fine. It's fine.
Okay.
Because at the end of the day it's okay.
So then, sir, we can also say that angle O1 is twice angle D.
Angle O1 is twice angle D. Yes.
Yes. Angle at the center is 2 times angle at the circumference.
Okay, so angle O1 is equal to what then?
It's equals to 120, sir.
Okay, 2 times 60, which is 120 degrees. And you said the reason is angle at center
is 2 times angle at the circumference.
2 times angle at circumference.
So basically, say this is my grocery list, Abona.
Oh, grocery. So you're still grocerying. Okay, yeah, because I was like, how is it attached to what we are trying to find? I see, this is grocery.
Yes.
So this is under grocery. It's not under your way to getting to the answer. Okay? No, it's fine.
So then, will I be correct, sir, if I say angle OBT, right? We said that angle OBT is 90, right?
Yes.
And then we say x plus 60 is equals to 90.
Definitely. Yes. So that's
which
definitely
is complementary, right?
Yes.
X plus 60 is equals to 90. Complementary, yes.
Definitely complementary angles. Then
my x is equals to 30.
X is equal to 30. Beautiful.
Yes, sir.
Okay.
Then
that's done.
Okay, now we are looking for which angle Z, right?
No. There's no Z. There's just the X and the Y. You are done.
Okay.
Thank you.
I thought that C2 was Z, so yeah.
Yeah. It kind of looks like it's Z, but it's 2. So yeah,
okay, so
you are 100% spot on. You've got us where we need to be. So thank you so much. That was good. Then we can move on to this last one.
Yes, sir, we can move on.
You are feeling the fire, so let's do this last one as well.
Okay, sir. Since I am told that angle line CT is parallel to the tangent AT, right?
Yes.
Yeah. So basically that's under my grocery. I've identified parallel lines. Sharp.
Sure.
Meaning that angle C, which is Y, will be equals to angle CPT, will be equals to angle CPT.
Angle?
Angle C will
Yes.
be equals to angle CPT, alternate angles.
This, you are
Yes.
saying, will be equal to CBT.
CPA, actually, CPA, sir, CPA.
Okay. Just wanting to make sure that you are sure about what you're saying. So
Yes, CPA.
So angle C will be equal to CBA. So this angle here.
Yes, sir. Yes,
So your
sir.
Z.
So,
shape.
and also given angle O is 140, and angle Y will be equals to say I think 70, say will be equals to 70.
Okay. What's the reason? Y is equal
Angle at the
to
center is twice angle at the circumference, sir.
two times angle at circumference.
Yes. Okay.
Okay, so Y is 70 definitely. We can update that.
Yes. So we're looking for Y, M, and X, right?
Yes.
Then angle X is equals to angle C.
Angle X,
Yes,
you are
sir.
saying, is
Is
equal
equals to angle C.
What's the reason?
Yes, sir. Tan chord, sir.
Okay. So X is equal to 70 degrees. Tan chord. Tan chord theorem.
Then angle OBA is equals to 90 degrees.
OBA is 90. So angle OBA is equal to 90 degrees. What's the reason OBA is 90?
That's the tangent perpendicular to your radius.
Tangent perpendicular to radius.
Radius. Yes, sir.
Okay, that's fine. So we have 90 there.
And since I stated in the first part that CT is parallel to AT, meaning that angle Y will be equals to angle CPA.
Okay. Y, which is equal to 70 degrees, is equal to angle CBA. CBA, yes. Reason?
This part is alternate angles are equal because CT is parallel to AT.
So we say alt angles, very important. Semicolon.
Yes, CT
CD
is parallel to AT.
Parallel to 80. Very important. Okay. Very
Yes, sir.
important. Very true.
Sorry about that.
So we
Yes, sir.
update 70.
Now we update our sketch. Yes.
Yeah.
Now we're going to say M plus 70 is equals to 90 complementary angles.
Awesome. M plus 70 is equal to 90 degrees. Complementary angles.
Yes, therefore my M is equals to 20.
M is equal to 20 degrees. Wow. Amazing.
Yes, I'm sorry to the people that do not understand tan chord H source.
No, it's no problem because it's good because it leads us into basically that theorem. All right. Thank you so much, Odysseus. What's your actual name?
Angelo, sir.
Angelo. Okay. Well, it was a pleasure, buddy. Like, thank you so much. That was so well done. Like I even heard some lingo that I'm quite familiar with. The term grocery list. That's a term that is used. Not too many people use that term. Grocery list.
Yes, sir.
Yeah, I'm thinking of a particular individual when you say grocery list. You don't happen to be part of a particular program, are you?
I am, sir.
Which one?
Euclidean Pro Maths and Science, sir.
No, I figured, man, because hey, that language of grocery list is a language that is used in that program.
Yes, sir.
Yeah. Which center are you at?
Katlong Center.
Oh, beautiful. One of the best in the country. And which grade?
I'm in grade 12, sir, currently.
Oh, nice. You're writing tomorrow, man.
Yes, I am writing, sir.
All right. Well, everything of the best for tomorrow's test, eh? I'm sure
Yes, sir.
it's grade 11 aspects, eh? Anyway, so grade 11 aspects, paper 2.
Yes, paper 2, sir.
Yeah, no, you must chow that one. Hopefully, you let me know how that one went, and if you were
Yes, sir.
able.
I'll definitely let you know, sir.
Yeah. Okay. Cheers, buddy. Thanks.
Yes, sir.
All right. All right. Okay. Let's open the comment section. It's been quiet, eh? Surely people have been feeling like, where are the comments? Where are the comments? Okay, let's restore the comment section. let's restore. Let's restore the comment section. Yeah, people. All right. Yeah, some of you guys are really good with the maths, eh? You just, just this flow in the maths, eh? No problems, eh? People move from one thing to the other, no problem. Non-atheist. Let me give you guys a chance. I want to give you a chance. Don't worry. I see non-atheist. You wanted to join. Oh, Jesus is goated. Don't worry. I'll give you a chance. I'll give you a chance just now. I'll give you a chance just now. Don't panic. You mustn't panic. I know you've been waiting. The thing is, remember, there's a lot more other people, okay, that have been wanting to join, okay. No, Max, I told you, Max. I told you. I'm not gonna do that. I'm not gonna do exam questions yet. I know where I'm going, right? You should chill, calm down. Yeah, okay, Matt. The Odysseus' confidence is on another level. It's beautiful. It's beautiful to watch. It's nice when learners have a good grasp of the mathematical concepts, but you can also owe it to the fact that he is part of an amazing program. That ProMaths program that Odysseus is part of. Glad is giving us his grocery list. No, total. It's part of a prestigious program, and they don't play there. They don't play. Excellence is everything there. Performance is everything there. Getting 90% and above is everything there. Mathematics, mathematically concerned. So it's beautiful. It's so nice. It's so nice to have people like that. Even Presh, guys. Presh did some things here as well. Like, those two problems, the way that she moved from one problem to the other. It's beautiful. Okay. It's beautiful. So I love this. I have to compliment that. I have to compliment the good work that I see. Even the people that came on previously before that, okay, the way in which people are able to look and navigate through the problem and still be able to get to the respective answers. It's beautiful, guys. I love it. Okay. Beautiful, beautiful, beautiful. Plus, I cannot state how much this actually helps with the live sessions to become a little bit more lively. Okay. Gladys, we also want to be in the grocery list program. Unfortunately, guys, that program, the intake happens in grade 10, and then learners are taken through grade 10, 11, and 12. All right, through that program. Kutlanong ProMaths program is one of the best in the country, and they're doing amazing things. Amazing things. Okay. Kutlanong ProMaths. Okay. That is the name of the program. Kutlanong. It's an amazing program. It's by far one of the best in the country, I must say. Helping the black child to really reach levels of excellence that would previously not be feasible or possible. But yeah, learners that come from that program, they come out very well seasoned. Yes, I just wanted to, whilst we are here, I wanted to cover the two I'm gonna allow you guys to join. Okay, don't worry. Offense, I hear you. Don't cry, man. Please don't cry, guy. Don't cry. Okay. I wanted to look at the two other theorems that have to do with tangents. Okay. And the one theorem, my good friend Odysseus was able to really touch on that particular theorem. Okay. So the first one, the first one is what we call the tangent chord theorem. Okay. And what it says is the following: the angle, right, whilst we're still here, between a tangent to a circle, the angle between a tangent to a circle and a chord drawn from the point of contact is equal to an angle in the alternate segment. Now, it's a lot of things that they write there that's in this theorem. And remember, guys, the reason why I insist on us writing down the wording of the theorem and then unpacking it is because sometimes in exam questions, they will give you the statements of these long theorems and they will say fill in the missing word or fill in the missing term. All right, so that's why it's important to know the theorem. So it says here the angle between a tangent to a circle and a chord. So let's come here. This is a tangent. This here, look at this. You have 1, 2, 3 chords, right? These 3 chords make up the triangle that you have that is internal to your circle. So all these vertices, they touch the circumference of the circle for the triangle. But these lines are chords, 3 chords. But there's this tangent, all right, which at the point of contact makes an angle, all right? So let's say the angle between a tangent to a circle and a chord. Which angle? This angle between a tangent and a chord. So there's this angle that's this side between a tangent and this chord. All right, then there's also this angle on this side between this tangent and this chord. Okay, so I've decided to draw one strap to basically indicate this angle, and I've decided to draw 2 straps to indicate this angle, just to show you that these 2 angles are not the same angle, but they are both angles formed by the tangent and the chord on this side, this angle. Angle formed between the tangent and this chord on this side. Are we together? So what are they saying? The angle between a tangent to a circle and a chord drawn from the point of contact. Remember, this chord here is drawn from this point of which contact? Where the tangent and the chord contact or meet. Okay, so I repeat, the angle between a tangent to a circle and a chord drawn from the point of contact is equal to an angle in the alternate segment. Listen now. Listen and listen very well. you will remember that in this angle here, all right, this one, the angle formed by this tangent and this chord, this angle, they are saying that this particular angle will be equal to which angle? Please, guys, note as well that this angle here is in this segment. Remember, a segment, this would be a segment, this area here. This chord allows us to have this small little segment. This same chord has this major segment because this chord closes off and we have this major segment. This is the segment, the segment on the other side. So this chord subtends this angle, this one. So they are saying, in other words, this angle is equal to that angle, the angle in the alternate segment. So in the other segment, there's that angle, which is this one. So this angle formed by this tangent and this chord is equal to the angle that is subtended by that very same chord. So opposite this chord, you have this angle. So that's why this angle and this angle, they are equal. What is forming this angle here? It is this tangent and which chord? It is this chord. So this chord subtends which angle? That angle. So therefore, these two angles, they say that they are equal. That's what Tangent Theorem states. The angle between a tangent to a circle and a chord drawn from the point of contact is equal to an angle in the alternate segment. This here is the alternate segment. This was the minor segment. This is the major segment. So the angle in the major segment is the angle in the alternate segment. Just something to note, it is the angle subtended by this chord here. Okay. All right. Yes, I do repeat a lot, and that's important for me. All right. It's important for me, and it's important for those who are listening. Okay. I don't know if you mean that in a negative light, because if you do, then please gravitate away from the live. It's as simple as that. Okay. Then, guys, there's another angle that is formed by a tangent and a chord, this chord. But remember, this chord subtends which angle? This angle. Are you with me? So therefore, I'm going to write a star here. This angle would be equal to this one, because this chord subtends this angle. Are you with me? All right. Yeah. Karabo. The angle between a tangent to a circle and a chord. Which angle? An angle there between the tangent, this tangent, and this chord, that angle. Then the angle between a tangent to a circle and a chord drawn from the point of contact. Guys, this is the point of contact. This is the point of contact. Where the tangent and the chord meet, this is the point of contact. This is the angle formed. All right. That angle is equal to an angle in the alternate segment. In simple terms, they would be saying that this chord subtends that angle. So therefore, this angle that this chord subtends is equal to this angle that is formed by the chord and the tangent. Remember, this chord and this tangent form this angle. This chord subtends that angle. So therefore, this angle is equal to that one. So this one is equal to that one, whilst this one is equal to that one. This one is equal to that one, whilst this guy is equal to that one. Okay. So you can screenshot this here, guys. Very critical and important, this theorem. Okay. It's called the Tan chord theorem. Okay, that's what it's called. Whenever you use it and you write the reason, you write Chord theorem. Chord THM. Chord THM for short. Right? Whenever a tangent and a chord form an angle, and that angle is equal to the angle subtended by that same chord, we call that the Chord theorem. This is the theorem that our good friend Odysseus was using when he was saying that certain angles are equal to another angle, because he was seeing a tangent, he was seeing a chord, and then he was seeing an angle being formed by where the tangent and the chord meet. And then that chord was subtending a certain angle, but that angle needs to be subtended at the circumference, guys. It must be at the circumference. If it's not at the circumference, then it's not chord. Okay, so these are the conditions. The angle must be formed by a particular tangent and a chord. Okay, then that angle is equal to the angle that same chord subtends at the circumference. That's kind of like saying it in other loose terms. The tangent and the chord form an angle. That same chord subtends a particular angle at the circumference. That angle is equal to that angle that is formed by the tangent and the chord and that particular chord. Same thing this side. There's a chord and there's a tangent. There's an angle formed. Subtending this chord is this angle. So this angle is equal to that one. Are you with me? Okay. And they are equal, guys, in different ways. If this is 50, that's equal to 50. That maybe, let's say, would be 40. That's equal to 40. Okay. Chord theorem. Chord theorem. Chord theorem. All right. So that's for an acute angled triangle inside the diagram, but you can also apply for an obtuse angled triangle. So I just want to show you here a situation where maybe we may have an obtuse angled triangle. Okay, that triangle there, let's say the tangent is here. Let's say that's the point of contact. Remember, there's an angle formed this side. Okay, this is the chord, this is the tangent forming an angle. This chord subtends which angle? Here. So this angle and that angle would be equal star. That chord, this tangent form this angle, and then this chord subtends which angle? There at the circumference. So this guy would be equal to that guy. Okay, so chord, guys, chord all the way. Okay, chord. Okay, so very, very important. Max, I don't tackle exam questions until I have concluded the explanation of the concept together with the exercises that are basic, that help you to be able to hammer in the concept. After doing that, then later on, when I've concluded, I'll go to exam questions. I don't do exam questions, me personally. That's just my philosophy, and it's a recipe that's working for me, and it's working for my learners at my school. And that's why the marks, they take the nice toll that they take, because my learners understand the concept and they can apply the concept everywhere. Okay, so it's very important, that thing. Very, very important. So let's come back here. I'm sure you saw when this young man that just joined my live was using the Chord theorem. You remember in this problem, he used the Chord theorem. Let's just check it out here. Okay. When he started off, he said angle CBT. Okay. OBT. He started there, said OBT is equal to 90 degrees, which is true. Why? Tangent perpendicular to radius. No problem. Then after that, he said CBT. Meaning, guys, this angle. Remember, this angle is formed by this chord BC, and this tangent ABT. So it's the angle between the chord and the tangent that is formed at the point of contact. Because of the point of contact, the chord from the point of contact, the angle formed between the chord and the tangent. What is subtending this chord? It is angle Y at the circumference. So that's why this young man said angle CBT, the angle formed by the tangent and the chord, is equal to Y, because Y is the angle subtended by the very chord that forms the angle that the tangent and the chord forms. So that's why he was able to say CBT, angle CBT is equal to Y is equal to 60 degrees. And he said tan chord theorem. That is the application of the tan chord theorem. All right. Then the other problem where he used the tan chord theorem was the second one, where he said X, right, here. Because we had found that Y is equal to 70, he was then able to say that X is equal to 70. If you look at the tangent, here it is. BD is the chord, and BD subtends which angle at the circumference? It subtends angle C, which is basically Y, which is 70 degrees. So that's why this angle formed by the chord and the tangent is equal to the angle in the alternate segment. In other words, the angle subtended by the very chord, okay, that formed this angle, okay, 70 degrees. So tan chord was applied very well and very successfully. Okay. So hopefully we understand the tan chord theorem very well, very well. Okay. Then I want to do the last tangent theorem. Okay, since we are here, you'll be joining now. I'll do some problems just now and allow you to join and do. Okay. Okay. Now this one has to do with tangents that come from the same point. Tangents from the same point. Same point, we could also say common point. What about tangents from the same point? So if you have two tangents, guys, no, and they are coming from the same point, now remember, a tangent would only touch once on the curve, once on the curve. So let's just imagine that this is a tangent touching once on the circle this side and on the circumference of the circle on the other side. So what does the theorem say? It says tangents from the same or common point are equal. That is what the theorem states. So what is the result of tangents from the same point? The result is that those tangents from the same point are actually what? And that is the critical point here. The result is that those tangents are equal. So that is the result, guys. This is what you would see in the diagram. You'd see two tangents coming from the same point, and then your conclusion would be the tangents from the same point are equal. All right. And this helps a lot. It helps a lot with other things whereby, for instance, we have to find, depending on the situation, let's say, for instance, they close here and they have a particular chord. You know, if they have a particular chord, then we know that if, let's say, this is B, and then say that's C, and let's say that's A, then we could conclude, because these are tangents from the same point, we could conclude that AB is actually equal to CB. And if AB and CB are equal, then we can say the angles opposite those sides that are equal are also equal, okay, because of angles opposite equal sides. So there's many things that we can then allude to, because we know that tangents from the same point are actually what? Are equal. So the reason that we use is tans from same point. Very important. Or we can say tans from common point. Okay, so they basically use that. Tans, you know, for short, tangents. Tangents from same point. Okay, so the theorem just simply states tangents from the same point are equal. That's all. Okay, so there are three fundamental theorems that we've learned today that have to do with tangents. The first one was that the tangent and the radius have a unique relationship in that the tangent and the radius at the point of contact form 90 degrees. There's a perpendicular state that results because of a tangent and a radius. Even if it's a diameter, obviously the tangent and the diameter will also be perpendicular. Because remember, a diameter is simply a extension of a radius to the other side of the circumference. So basically, tangents perpendicular to radius. Then the theorem that we've just looked at before we looked at tangents from the same point was the theorem that has to do with the tan-chord theorem. Okay, yeah, and we learned that the angles formed by a tangent and a chord at the point of contact is equal to the angle in the alternate segment, or in other words, the angle subtended by that very same chord. So we'd say this angle here would be equal to that one, and this angle this side will be equal to that one. Why? Tan-chord theorem. And then tangents from the same point. So I've done all three of the theorems that relate to tangents purposefully all at once, so that we all have a pretty much solid understanding of those theorems. Okay, so I'm gonna just look at a few examples, or maybe let's just turn these examples to actual problems that people can come in and look at. Okay, yeah, let's just do that. I know people that you've been listening to, a lot of people that I know these kids that basically, yeah, you can offense. I'll call you up just now. I know you guys have been listening to a lot of testimonies from a lot of learners, and I understand that they do talk about the importance of practicing past papers. I know that, yeah, but it's just that I'm one of those teachers that insists that first and foremost, before you even jump into the world of past papers, first get to understand the concept around that particular topic. When you understand the concept and you have fully gotten a grasp of the understanding of the concept, done sufficient exercises to actually make sure that the concept has been fully grasped, then exam papers can follow, they can flow. Okay, no problem. They can come and come and come. Value of unknown angles and your reasons, please. Okay. Okay. Let us. Sorry. Okay. All right. I think let's give some people a chance. I'll start from the back to the front. I'll start with this last question that I have here. Offense has been crying. Don't cry for me, Argentina.
Evening, sir.
Evening, Goku. Is it Goku?
Yeah.
What are you, a DBZ fan?
Yeah, an anime fan. I watch anime.
Anime. Oh, okay. Oh, that's powerful, man.
Yes,
I know. Anime has got quite some lessons in there. Let's jump in, buddy. You can lead us along here. I need X. I need Y. I need Z. This is my situation.
So you have triangle DEB, right? And
Yeah, DEB. Yes.
that angle is 30 degrees.
Yes, it is.
Okay, then there at the tangents from the same point we have 2 or Z.
That's Z. Yes.
Oh,
Yes. So that's Z. And then those are two equal yes, and then
yeah.
DE
We are given that line. Let's say DE is equal to BE.
yeah.
So X is equal to 30 degrees.
So X is equal to 30 degrees. Reason?
Angles opposite equal sides.
Okay, epic. Oh wow, okay. Angles opposite equal sides. Okay, nice. Then obviously there will be that update, yes.
Then angle Y, you're gonna find it with the sum of angles in a triangle.
Awesome. Can you tell me what my Y value is, or do you need me to actually add them there?
I don't have a calculator with me, but yeah.
Okay, let's
Actually,
do
it's 120.
Okay.
I think 120.
Okay, so 30 plus 30 is 60, definitely. Plus what gives us 180? It is 120 indeed. You are spot on. I'd say you seem to be very well calculated in your mind, if you ask me.
Nah, sir.
120 degrees. What's the reason?
Sum of angles in a triangle.
That's awesome. Sum of angles in triangle. Nice. Okay, I think so far we're good. We update the Y, we get 120 in there so that we can see what we have. Sweet, we are good. Now we need a beautiful Z there.
So we have the whole triangle, right?
Yes, we have the whole triangle. So now we have that 30 there. We have the 120 degrees. Oh, comments off, definitely. My goodness, how could I forget that important setting? Thank you. Forgot that.
Okay, so that 30 degrees at angle BDE.
BDE, that's 30 degrees. Yes, what about it?
it's equal to angle EBC.
EBC. What's the reason? Explain
Tan
this.
chord.
EBC. Tan chord. Wow.
Yes.
Great. That's beautiful. So just quickly, for those that may not see it, okay, I love the fact that you saw that. So that means this tangent, BE is a chord. There's an angle formed. Yes, because of the chord and the tangent. This angle will be equal to the angle subtended by chord BE. Chord BE subtends angle D, which is 30 degrees. 100. Wow. So you're saying, just say it again, you said angle?
Angle EBC.
EBC. Beautiful. Is equal to?
30 degrees.
Awesome. 30 degrees. Reason?
Tan chord.
Yeah. Wow.
But
No.
sir, I see two alternate. Thank you.
Yeah, that's beautiful. I just had to give you that clap there. That's beautiful. You see?
I see two different reasons of finding EDC.
Sorry, E? Who? EBC.
No, EDC.
EDC. Okay, EDC. What about EDC?
So we can find it by the same reason as we said. EDC is equals 30 degrees.
Reason?
Tan chord.
Sure. No, that's power.
Or we could have found it by saying that is equals to 30 degrees because tangent from the same point have equal size, so DC is equals to BC.
I see. I hear you there. All right. I hear you. So just for those who may not see the EDC, so if you take your picture, you turn it around, because remember with geometry, sometimes you have to do that. So EDC, this angle here is the angle formed by this tangent and chord DE. So this angle here. Okay. Then if you look at the chord, it subtends which angle? It subtends angle EBC, which is 30 degrees. Yeah. So that's beautiful. Thank you so much for that. That's sight for sore eyes. So 30 degrees, we have 30 indeed there. We have 30 as well there, which is amazing. All right, we good.
Yeah. Then
We need
that
Z.
angle Z. Yeah, we can find it by the sum of angles of a triangle.
Awesome.
Cool. So 180 minus 60 plus 60.
Okay, so it's 180 minus, that's 60 plus 60. Very important there. So we're saying what? Sum of angles.
Sum of angles in a triangle.
Triangle.
Yeah.
Okay. All right. So that's 180 minus 120, which is equal to 60 degrees. Sure. No. Now I can see why you were bending so hard to want to come on here, eh? Because you know your stuff. You are yeah. Yeah. Sure. Okay, that was just hands down, just yeah. All right. Offense. Would you care to do this last one then? I think this is me trying to make up. I know you were dying to come on here long time ago.
Also, yeah, this is the last one.
Yeah, this one is the last one for you, so that I can give other
sessions.
Yeah. So this one.
So I think that we should say that. Sir, can you please give that point, that tangent from the same point, like a letter?
Tangent from the same point.
A letter. Yes.
Oh, this part, yeah. Oh, actually, there is a letter here. It's just that I forgot to write it. It's P.
So
since those line AP and line AT
Yeah.
are tangent and they are from the same point, that means they are equal, and then we can say that angle A or angle T3 is equals to 180 minus 50 all divided by 2.
Okay. So say that again. You said. So where do we start? First and foremost, we start by saying what at the beginning?
We say that AP, I think we should start by saying AP is equals to T3. AP is equals to TP.
Okay, very good. AP is equal to PT. Reason?
Tangent from the same point.
Okay, good. Tans from same PT. Okay,
Yes.
that's true. That's the first thing we say. Then
Therefore, we can say that the angles are equal. So angle A is going to be, or T3 is going to be 180 minus 50 all divided by 2.
okay. Okay. So
65.
T3 is equal to A. What's the reason for that?
The reason is I think it's still tangent from the same point. I don't know. I'm not sure.
Okay. So you discovered that the
lines are equal.
So
because
now
they are
why do you say the angles are equal?
angles opposite equal sides.
Very important, very key. That one.
Yes.
Okay.
I wasn't
Then
sure
from
of that.
there, no problem. At least now we know.
Yes, sir.
Okay. So you know both are A. Now you can actually go on to the next step, which is what?
Calculating them.
Exactly. So
We are going to say 180 minus 50
180 minus 50.
is equals to 130 divided by 2.
Okay, is equal to. So I'm guessing you had the 2A is equal to 180 minus 50, which is reason.
Yes, sir.
Your reason was?
Sum of angles in a triangle.
Yeah, sum of angles in triangle.
A
Very
triangle.
important for that. 2A is equal to 180 minus 50, so 130 you said.
Yes,
Divided by 2.
65.
So, beautiful. 65 degrees. All right. Yeah. Okay, coming on nicely. We've got A is equal to 65 degrees. So we update that. We can say 65 there. We have a 65 there as well. We have 65, 65, 50. We want B. And then ultimately we want C.
We can find B. We can find C first, sir.
Awesome. How?
So I see that it's either we're gonna find it by the tangent AP or tangent TP.
Awesome. Okay. I'm listening.
So angle C is equals 65.
Angle C. So C, you are saying, is equal to 65 degrees. What's the reason?
Tan chord.
Sure. Okay. I love it. Tan chord theorem. I'm sure you guys can see it, right? If you're looking at this side, like he said, this is the angle formed by the tangent TP and the chord AT. Okay, and that angle, right, is formed by this chord and this tangent. This chord here, AT, subtends angle C at the circumference. So that's why we say this 65 degrees is equal to C. Or we can look at it from this side. Remember, this was also 65 degrees formed by the tangent and which chord? Chord AT. So therefore, the same thing can apply here, that this angle is equal to C. So either way, C is equal to 65 degrees. Tangent chord theorem. Okay, very good. Beautiful. Thank you, man. C is 65. Then we want B after that.
Then we can see that B is the center and C is the angle at the circumference. So the angle at the center is 2 times the angle at the circumference.
Awesome, bro. Awesome. So that arrowhead, ne? That arrowhead where the center is here. This is the arrowhead. I'm sure you guys can see it. The arrowhead diagram. So the center is here. The circumference, the arc subtends angle at the center. Same arc subtends angle at the circumference. So yes, B is equal to. So B would be equal to what?
130, sir.
Thank you. 130 degrees. And reason?
Angle at the center is 2 times angle at the circumference.
Sure. Aye. Guys, offense is not offensive at all. Offense is very delightful. That was flawless. From one place to the other, just spot on. Just like I said, for this part, just make sure you are clean cut with these. I remember here you kind of had a bit of a glitch there, but just make sure that we know this angles, opposite equal sides, especially after sides have been established that they are equal.
Yes, sir.
And then formalization of when you are using sum of angles in a triangle, just make sure you formalize it and are able to write it down properly. Otherwise,
Yes, sir.
my leader, you are the one. You guys are like, oh my goodness. You should. I am sure the marks for maths will be popping for days this term. Yeah. No, keep it up. Thank you so much, Offense. Really appreciate you joining in. And yeah, stay
Thank
awesome.
you, sir.
Stay awesome, bro. Cheers.
Thank you, sir.
That's all right. So Mioli wants to come and finish off our day. I think this is nice. Okay, Mioli just disappeared there. Right. I know there was someone else here that basically was also crying that I did not accept their invite. Was no one else? Okay. All right, guys. I think that was okay. Good. Just need to finish off now. Let's close off this session with these last two problems, and then let's call it a night for now until further notice. Let's call it a night for now. I can leave you with your game challenge problems, and then you can do those. But I'm not going to write them down. I'm just simply going to show you on the screen, and then you guys can actually do them. Okay. So who's wanting to just come and close off the session for us? I should have just continued with Offense. Offense, you should have just closed off the night. Might as well. I think, guys, he's the one that requested. Might as well. I see you jumped for the opportunity. Might as well finish it off, eh?
Yes, sir.
Yeah, let's finish it up, man, because this will be the concluding problems, and then I need to call it a night. Otherwise, I am not going to wake up. I can see myself not waking up tomorrow.
Okay, sorry, sir.
No problem, man. No. I don't get me wrong. I'm just saying, hey, I need to wrap up now, hey.
Yeah. I also said I need to go rest now because tomorrow is a big day.
I know. Okay.
Yeah.
There we
So,
want.
which one should I start with? The second
That
one
one,
or the
that's
first
the
one?
one. No, the first one. Let's start with the first one.
The first one.
Yeah.
So say because we know that APT is a tangent to at point P, right?
Yes.
Yes. So given that EPT is equals to 65 and EPA is equals to 72, right?
Mm-hmm.
Then angle E is equals to angle BEF is equals to 65.
BEF is equal to 65.
Yes, which is basically angle E. Yes.
Yeah. BF
is Y.
equal to Y, which is equal to 65 degrees.
65 degrees. Tan chord.
Okay, Chord theorem. Yeah, guys, we're taking it to bed now. Like, yo, we're taking it to bed. Yes.
And
Very
also
true.
angle BFE is equals to 72, which is x.
BFE is equal to x, which is equal to 72 degrees. Reason?
Chord theorem, sir.
All right. Forgive me, guys. I know, same reason. Just, yeah, got it there.
Yes.
BFE, yes. Right, we're done with that one. X and Y. Now we just need to M, X, Y, and Z.
Okay, sir. We are given points that lie on the circumference, which is D, F, E, and B.
Yes.
Yes, sir. So can I conclude that DF or DBEF is a cyclic chord?
D, B, E, F is a cyclic chord, of course. Points, yeah.
Okay. And then I see that ABT is still a tangent, right?
Yes, it is. Definitely indeed.
Therefore, X is equals to 55 degrees.
X is equal to 55 degrees.
Yes, sir.
Yes, this tangent, this chord subtends angle at the circumference for the triangle, the chord, definitely. So you said X is equal to 55 degrees. And your reason is tan chord.
Tan chord.
Awesome.
Yes, sir.
Aye.
Now, sir, my question is, where does that 75 belong to, sir?
So this 75 is for the whoops. This
For the whole
50 is
entire
for-
angle.
Yeah, the 50 is just for this one.
Oh, the 50 is just for this one.
Yeah, and then 75 is
50.
for.
So, sir, 50 is EPT.
Yes, 50 is EPT, yes.
Yes, so the angle, and then therefore angle Y is equals to 50.
Very good. Y is equal to 50 degrees, no doubt. Reason?
Tan chord theorem, sir.
Okay, so this
Because
tangent.
BE subtends, yes.
Yes.
And they have a chord,
yes.
the chord BE
Chord
subtends,
BE, angle
yes,
Y.
subtends Y. Yes.
Okay, Y is equal to 50 degrees, tan chord again.
Okay,
Tan
sir.
chord is loving us here. Yes.
Wait a
Update.
minute, sir. Update, then also X there, 55, update.
Update, yeah.
So you said that 75 says it's for the whole angle, right?
Yeah, it's for the entire angle, yeah.
Okay. Let me see something here, sir. I see something, but I'm not sure if it's correct.
Yeah, it sees you too. You must see each other.
Yes, sir. Oh, sir, angle B F angle angle FBE.
FBE.
Yes, sir. Will I be wrong if I said it's equals to 75 minus 50?
B, yes, 75 minus 50. No, you won't be wrong. If you said B, if FBE is 75
Yes, sir.
minus 50, which is, yeah.
Yes, sir.
So you want to, is that your grocery list? You want that to be that's part and parcel. You are putting that in, right?
Find the value of M,
Okay.
right?
So,
Yes, so meaning that angle FBE, is FBE, right?
yeah,
Yes, is equals to 25.
is equal to 25 degrees. Yeah.
Yes. And then in triangle FBE, you want to find E2.
Triangle FBE, you want to find E2?
Yes, so therefore we're going to say angle E2 is equals.
Oh, you mean Z. Sorry, that's Z. Sorry, that's not E2.
That's, yes. So you're going to find Z. Okay, so
Yeah.
yes. So angles due to sum of angles in a triangle.
All right. So Z is equal to 180 minus
50, which is 130. 130 minus 25, which is 105.
So it's 105 degrees. And the reason,
Yes, sir.
sum of angles in a triangle.
Sum of angles in a triangle. So now we want to find value of M, right?
Yes, sir.
Yes. And then we said that DBT DBEF is a cyclic chord, right, sir?
Yes.
Therefore, angle FEB plus angle BDF.
Okay, yes.
Yes. Is equals to 180. Opposite angles of a cyclic chord are supplementary.
All right, nice. Okay, so I see that.
Yes.
So angle, in other words, M will be equal to 75 degrees. And you are saying opposite angles of cyclic chord.
Are supplementary.
Okay.
Yes, sir.
Yeah, opposite angles of cyclic chord is sufficient, right? Where,
Yes, sir.
yeah, for the reason that's acceptable according to that acceptable reason document. So yes, it's M is equal to 75 degrees, opposite angles of cyclic chord. 100, no problem. Okay, definitely a route that you took, no problem. I mean, other people could have taken other routes that would have led them to the very same accurate answers. As long as our statements and our reasoning, they are actually logical and sound, no problem, and they lead us along. Okay, thank you
Yes,
so
sir.
much, Odysseus. Again, yeah, all the best for that. What is the grade 11 concepts test? I'm sure it should be good actually exam, because you pretty much
Yeah.
write full exam again.
Yes, sir.
Paper 2.
Yes, sir.
Yeah, you must share that paper after you have written it, my leader. Actually, at the time that's relevant, because I know that it seems like you guys don't share papers immediately, or at all, depending on the situation. Yeah.
Yes, sir.
Yeah. But thanks again for joining in, and thanks for being a sport. Really appreciate your enthusiasm. I'm sure you saw the comments. People were really pleased with how you were doing the things. They want to go to the program that you are part of as well.
Yes, sir. Yes, sir. That's how we promote, sir.
Yeah, that's how we promote.
Yes.
Oh, okay. No, that's good. That's good.
Yes, sir.
We await great things in future then, my friend. Thank you so much.
Thank you, sir.
Thank you.
Also
Have a
gain
lovely-
more followers. Thank you, sir.
No problem. No problem. I'm happy. They must follow you, and then they must ask you the questions and harass you.
Yes, sir. Which is a good thing. Yes.
No, sure. Have a good
Thanks,
one.
sir.
Cheers.
Nah.
Okay, guys, thank you so much. That, I think, was a very pleasant session. You guys have been really kind. You've been very patient. I know that in certain moments in this live session, some of it has not been so great. Maybe certain things we didn't hear very well, but yeah, you guys have been amazing. Thank you so much. I have to retire, otherwise I love what my good friend Presh said earlier on about we are not done until we are done, being tired and stuff. But I have to go now, because I'm telling you, I have to. Otherwise, long day tomorrow. Guys, don't expect me to go live tomorrow, because it's a very long day tomorrow. It's a very hectic, long day. But we'll see, maybe Monday. All right. Because what I want to then do is that when I come back on, when we continue with geometry, we will maybe what you can do, very quickly. So this is exercises from mind action, guys. So please, I mean, if you have mind action, then it's great. I think it's page 238, the old mind action series textbook. You guys these are the exercises that you can do. Why these exercises? Because we want to hammer in the concept of what we have just done, for tangent theorems. So please make sure that you are screenshot these, do them. If you have the textbook, then please go ahead and do them. If you guys haven't gotten there yet at your school, that's fine. Still, go ahead and do them. Get ahead of the game, get ahead of the game. So next time, when we meet, we'll have the continued session. We will look at, we'll go and relook at the other theorems, because I think we've pretty much covered most of the theorems with their corollaries as well. So what I want us to then do is I want us to go back and look at proof type problems. Okay, maybe look at these corrections, look at proof type problems, so that we can see how the converse theorems are applied whenever we are supposed to prove a certain theory. To prove, for instance, that lines are parallel. To prove that a quadrilateral is a cyclic quadrilateral. So we're going to see how the converse theorems assist us in that. To prove that a line is a tangent. Okay, so we'll look at those things specifically and look at how do we go about, all right? Because once we know the proof type problems as well, we're able to prove parallel lines, we're able to prove that a quadrilateral is cyclic, we're able to prove that a line is a tangent, all right? These are critical questions that tend to be asked in geometry where you are supposed to prove, but you need to know how to approach those kinds of questions. So we look at the converse theorems in light of that. Then, before we even jump into the writers, I then want to go and look at the theorems that we need to prove. Not all theorems need to be proved for exams. Not all theorems are examinable. There are 5 theorems in these, all of these theorems that are examinable. So we're going to look at those theorems that are examinable. And I'm going to show you how to prove each individual one, the ones that are examinable. I'm not going to do all of them. I'm going to do only the proofs that, the theorems that are examinable, the proofs of the theorems that are examinable. The rest is something that your teacher must do at school. I'm not going to do the other things. Then we'll look at riders. We'll look at riders, all right? We'll look at the textbook riders first. Then after we are done with the riders and we've done numerical type problems, we've done variable type problems, we've looked at proof type problems, then guys, we'll do your exam type problems, okay? And I'm telling you, by the time you do the exam type problems, you should be then at a position where you can say, "Hi, Suka, I can see this thing." Exam type problems won't be a pain. So please do me a favor. If you joined today for the first time, you need to go to my YouTube channel. You need to go to the live lessons I've done previously. You need to catch up on what we have done so far. Especially if, let's say, you haven't started geometry at your school. Please go and catch up on what I have done so far. Go and relook at the lessons. I plead with you, I beg you, so that you can get the basics of each theorem in. Hello babe Zoe. Thank you so much for the hello there. You seem very eager and happy to actually have come into the live and to be greeting me. Thank you so much. Hello. I reciprocate the energy. So please go and look at my, like I said, the YouTube channel. Go to my link in the bio. It's Maths is a Game, capital letters, Maths is a Game. Then there's a grade 11 term 2 playlist for grade 11, term 2 playlist. You go there to the playlist, you'll see all the lessons that I've done, the live lessons that I've done, the interactive live lessons, where I've explained the theorem, shown the diagram, done examples, allowed learners to answer and interact with me. I've done the same thing. I've uploaded those lessons. I'm going to also save this video and I'm going to download it and upload it onto the same channel. And I'm going to head it, like put a heading of tangent theorems, you know, so that you guys can actually follow along. And then each successive lesson, I'll do the same thing. So please, guys, this is just me trying to sort of like do my part in helping you. Okay, many learners have said to me that these lessons have been helping a lot. Some learners have told me that, for instance, in some of their schools, they don't get taught at all. There are challenges with teachers not being there and so forth. So my heart has really been one of, let me then do my part here in these live lessons and try and do a bit of justice, okay? And please do contact me on the side if there are serious issues, especially as it relates to your school, as far as like you no teacher, no nothing, because I'd like to support you and help you and assist you as much as I possibly can, above and beyond the help and the assistance that you are probably getting. Because at the end of the day, my strong belief is that maths is not difficult. Maths is a game. You just need to learn the rules. You need to understand what's there. You need to understand the basics, do the basics, apply the basics, you'll be good. Like, you should be able to soar in mathematics and get your high 90s, 100%. 100%, guys, is not a as something that is foreign. You know, you can get 100% for mathematics, clean, no fun. I mean, no joke. So yeah, that's something I really strongly believe, and it just means you just need to work at it. So please, guys, please do the most, do your part, and yeah, we'll see each other again when I do get the opportunity to come on and do a live lesson. I don't know, guys, when that will be. You're just going to have to keep a watch for when I do the lessons. But one thing you can be rest assured with is I'll always upload the lesson on my YouTube channel anyway. So if you've missed it, maybe you were not there, you can always go watch it and catch up. Unfortunately, you're going to also experience the ramblings of a madman as I ramble and say a lot of things sometimes that are not even related to the maths content, which are just advice, encouragement, and all of those things, you know. But thank you so much again. You guys have been great sports. It's 11:58. You guys have been here. Like, I've seen the numbers have literally been skyrocketing. You guys have been amazing. Please take care. Have a good night. I really hope this has really helped, like, more than anything else. And I pray God's amazing and most amazing blessings upon your lives, especially now as you go to bed. And to those who are writing tomorrow, like I said, the Kutlanong students and the Kutlanong students that are here, if you're writing tomorrow, go and kill that paper 2. You guys are being prepared for days because you're writing a grade 11 paper 2 aspect paper. That means June comes around, you are grade 12. June exams come around, you're going to kill it. I mean, you're going to kill June. You're going to kill September. You're going to destroy the final end of year exams. So there's no time to really, you know, muck around. And guys, please make sure that you go back to your schools and help those kids that are not part of the program and assist them with those certain concepts that you may have come across in the papers and so forth. Because by doing that, when you go and help someone else, you actually help yourself to actually become better in the content and in the subject matter. So yeah, thank you guys. Again, I've been saying thank you, but I really need to go. Thank you, thank you, thank you. Love all of you. Cheers. Bye. Goodbye. You better do that, Odysseus. You better ace it. You have no other option. Ace it with an extra ingredient, 90 and above, 95 if you can. It's very key, that thing. 100% if you can, that would be also even awesome. Okay. Yeah. Weekend to remember vibes. Cheers, guys. Cheers, guys.